it is about safe and unsafe state. Safe state means that all processes will finish its tasks, okay? Finish their tasks. And the unsafe state means maybe some of the processes can't finish tasks, okay? So unsafe state doesn't mean deadlock, okay? On the contrary, if there is a deadlock and the state must be a unsafe state, okay? But if the state is unsafe, maybe the reason it is not deadlock others, okay? In this example, there are 3 processes, okay? Process A, B, and C. The second column means the number of resources owned by each process, and the last column means the number of resources required by each process. Okay. For example, the first line is about process A, and process A owns 3 resources, but in fact it requires 9 resources. Okay. This is the meaning about this table, and the number on the table is the 3 resources. For example, there are total 10 resources. We have known that 3 plus 2 plus 2, 7. Yes, 7 resources have been allocated. So the 3 ones are 3. Yes. The total number is 10. The total number of the resources is 10, and 7 resources have been allocated 3 to 2. Yes. The summarization of 3 to 2 is 7. So the free one is 3, and it means that we can allocate the 3 resources to processes. Yes. In the figure B, we just compare these 2 tables, and we have found that 2 resources have been allocated to process
B.
Yes, process B got 4 resources. Okay, so the free number is 1. Okay, and in figure C, this free 1 resources is allocated to process B.
After allocated in the process B, we only free 1.
Yes, process B requires 4 resources, and now it gets 4 resources, so process B can finish its tasks. Okay, and then release these resources. So these 4 resources are now become free. Okay, so new 4 resources and 1 and this one, and 4 plus 1 is 5. So the free resources, the number is 5. Okay, and we can find that process B gets 9 and requires 9. Yes, because it has finished the tasks. Okay, so there are 5 free resources, and we allocate to process C. Yes, because process C gets 2 and requires 7. So in fact, it only requires 5 new resources. We just allocate these 5 resources to process C. So we can see that process C gets 7 resources. So these 2 numbers are equal. That means process C gets all it wants. So process C start to run and finish tasks, and then release the resources. So we can see that process C got this 9 and requires 9. Okay. Yes. So the free resources is 7. Okay, because these 7 resources are released by process C. Okay, so we will find that only process A doesn't finish its task. So we just want to enable process A to run. Okay, and we just compare the two numbers. Process A gets 3, and in fact it requires none. So process A wants to require the new 6. Okay, and in fact we know that there are 7 resources free. Okay, so we just allocated 6 of the 7 to process A, and the process A can also finish its task. So from this example, we can see that in fact, finally, each process can finish its task. Okay, so we just say that each state, these states are safe. Yes, safe means that each process will run and finish its task. Okay, so they are safe. But on the contrary, in this example, this table is the same. These two tables are the same figure A, but in figure B, we allocate there are 3 free resources, and we allocate 1 to process A. Different strategies. Okay. We just allocate 1 to process A. So process A gets 5 different strategies. Okay. So the free resources, there are 2 free resources. Okay. So we are considered to allocate these 2 resources. Maybe we can allocate to process B, because we find that process B requires 2 new resources. Okay, it gets 2 and requires 4, so only 2 new resources are requested. Okay, so we just allocated the free ones to process B. Then process B gets all its ones and can run and finish the task. And then it releases the resources. So the free resources, the number is 4. And focus on this figure. Process A and process C
didn't complete
completed the tasks, and we have 4 free resources. So can you tell me how to allocate these 4 resources to enable process A and process C to run?
From A.
For A.
So we need to prepare it from this table, from A table.
Yes, A table is the same with this one,
Yeah.
but we allocate a lot of allocation strategies and not go on here.
But for this strategy, 4 can't allocate because both process need 5.
Yes, process A needs 5.
Yeah,
Okay,
and process C also need 5.
is 5, but
their available is 4.
yes, we don't have 5.
Yeah,
We don't have enough resources, so it means that
it's unsuggested.
yes, process A and process C can't run. Okay, so only process B can run and finish its tasks.
Yeah.
So it means that here is not safe. It is unsafe. So return back. In this one is a safe or unsafe state. They are the same. Yes. It is also unsafe state because they are same. Okay. And then return back. This one. Can you tell me whether this one is a safe or unsafe state? It means that from this table, and whether you can make arrangement such that each process can run and finish the task.
Yeah.
Maybe not this way, but from here now. Can you find a way? Location?
This one horizontal state.
From this is the initial. We just see it as an initial state. Can we find a location such that each process will run and complete?
Yeah.
Okay, can you tell me?
Yeah.
How?
First in the B process.
Process B.
Yeah. We can allocate two resources and it will be 4.
Two resources to process B.
Yeah.
And
then
then
it will 4.
Yes, give here.
Yeah. And it will release and then we can allocate again.
Release. Okay, give
Yeah.
here.
It's all considered.
Yes. We will find that no allocation exists. Yes.
Yeah.
No allocation exists such that each process can complete. Okay. So this is the unsafe state. Okay. But this one. This one
is safe state.
Yes, it's a safe state because we can find a location such that
By this
each
institute.
process complete. Yes. Okay. So safe, unsafe, unsafe, unsafe.
Yeah.
Okay. So from this example, the allocation about resources is just to it's just to make the state safe. Okay. Yes. If we want to make a allocation about the resources, we just to maintain each state is safe. Instead of unsafe state. Yes. So there is a famous algorithm, Branker's algorithm, about how to allocate resources, and the purpose is to avoid deadlock. And the main idea is to avoid unsafe state. Okay. The first algorithm is about singular resource. We can also imagine that there is only one banker. A banker, you can view a banker as a resource because customers require money from banker. Yes. So a banker just is a resource. This algorithm about one banker. Okay. So we see that there is a singular resource, only one resource. There are A, B, C, D, 4 customers. Each customer, we can see that we can view each as which? What? Banker and customers. Banker is a resource. So a customer is okay. I think that you can turn your book, chapter 6.
Page number
418.
Yes. 453. I resume about to single resource. I have just said that a banker and the customers, yes, customers request money from a banker, okay? So we can view a banker as a resource, and the customers are represented. What?
Process.
Yes. Great. So customers represent processes, okay, in operating system, okay. So there are 1, 2, 3, 4 customers. We also see that 4 processes. Each customer requests money from the banker. Okay, the customer A requires 6 units. Maybe 1 unit is $1,000. Okay. Customer B, customer C, and the customer D. And this banker has total 10 units. Okay. So the banker will think about how much it can allocate the money to multiple customers. Yes. For example, in figure B, this banker allocated 1 to customer A, 1 to customer B, 2 to customer C, and 4 to customer D. So this bankers has only 2. Yes. And the next, this banker allocated 1 to process D, and finally it is only has 3. Yes. Okay. In fact, we focus on this one. We focus on the figure C. On figure C, we will find that
that one is unfinished.
yes. No matter how this banker allocates this 1 unit, no customer will get the money it requires. Yes, because this is only 1. Customer A requires new 5. Yes, requires 3, okay. Requires new 2 and requires new 5. But there is only 1. Okay. So now, yes, yes, no customers will get the money it wants. Okay. This is unsafe. Return back. Can you tell me this is safe or unsafe?
That one is stable state.
If you think it is safe, you can tell me how to allocate the
First
first two
in process C,
allocate to
allocate
C.
process C, yeah.
Okay, and then the
Then
free one are 4. Yes,
yeah. Then we can allocate process B or D.
yes,
Or
B
A.
or D.
B or D, not A.
Not A,
Yeah.
because B requires 4
Yeah.
and D requires
Three.
3. Okay. Okay, and the B and the D we are finished.
Yeah.
Okay, then the free one is
And then we can put in the process A.
yes, the free one is 9 because the total number is 10. Okay, the free one is 9 and the process A only requires 5
Correct.
unit. Okay. For resources, so we can allocate it to process A, and then each process we are finished.
Yeah.
Okay, so this is safe. Because this one is safe, we can also say that this one is safe. Yes, there is a allocation. Safe, safe, and unsafe. So the main idea about allocation for a singular resource is just to find a process. If these free ones are enough for a process, we will first allocate the free ones to this process. Okay, we have learned this simple idea. Okay, next. This algorithm is for singular resource, and then this one is for multiple resources. We just see that there are multiple bankers,
Yeah.
and a customer can request money from one banker and can also from another banker. Multiple resources. Okay, you can read this example first in your book. Okay. About multiple resources. Can you tell me this tuple, the meaning of this tuple? Okay, you can have some more minutes.
Same have 3 plotters, 2 printers and 2 Blu-ray.
Okay. What does the tuple E means? Can you tell me? The 6 means what? 3, 4, and 2 means what?
6 tape drivers.
Yes, 6 means
Tape drivers.
there are total, the number of resources. There are total 6 tape drivers, okay, and 3 plotters, 4 printers, 2 CD-ROMs. This is the number of the total resources for each type, okay. And this tuple means T means what? This tuple, the meaning of this tuple T.
Available resources. Processed resources.
Process,
Resources.
yes. The number of the resources have been assigned. For example, 3 assigned for A, 1 assigned for C, 1 assigned for D. So 3 plus 1 plus 1, 5. 5 of 6 have been assigned. Okay. So the meaning of tuple A, the meaning.
Available resources.
Yes, available resources. For example, tape drivers, there are total 6 and 5 have been assigned. So the available number is 1. Okay, you will find that 3 minus 3 is 0. 4 minus 2 is 2. Okay, 2 minus 2 is 0. So the first one is the total number. The second one is the assigned number. And the last one is the available number. Okay? For each type of resources. Okay? Is there any problem? Tuple A is the available resources. And this table is the still needed resources, okay, for each process. Okay. For example, process A got these resources, but it requires these resources. Okay. So this is the resources still needed. Okay. This is how it is.